Imagine standing in a place where the sun dominates every inch of the horizon. The air is dry, the sand is scorching, and for Felix, the fennec fox, the canteen hanging from his belt is dry. Felix is a real-life survivor. These foxes live in this harsh environment every day, using those oversized ears to radiate heat and stay cool while they navigate the dunes. But his robot companion, NOT, points out the obvious problem. There are no rivers here, no rain clouds, and certainly no taps to turn on. To find water in this landscape, you have to look past what the eyes can see. NOT activates a specialized scanning mode for Felix, allowing him to visualize the moisture that isn't visible on the surface. We're going to follow that scan to see where the water is actually stored in a landscape that looks empty. Felix looks straight down through the sand. The scanner reveals a massive supply of water, but it's trapped deep underground. This water starts at the base of distant mountains. When it rains in the highlands, the water trickles down and settles into rocky layers far below the desert floor. Long before modern machinery, people found a way to reach those deep mountain reservoirs. They engineered a system called a kanat. This works like a long playground slide. By digging a slanted tunnel from the mountain base toward their homes, builders created a path for the water to travel across miles of desert. Because of that steady slant, gravity does all the work. The water slides down on its own, providing a constant flow to the village without the need for electricity or manual pumping. These ancient structures were once the centers of massive desert communities. These civilizations thrived in the heat because they mastered the art of moving water from the mountains to their doorsteps. You can still see these engineering marvels today. This stone-lined canal sits deep underground, where wooden posts support the tunnel and keep the water flowing through the dark. Keeping the water in these tunnels protects it from the sun. Since the heat can't reach it, the water won't evaporate, allowing every drop to reach its destination safely. While the kanat is impressive, it's deep under the sand. NOT directs Felix to look up at the clear sky. Even when it isn't raining, the air itself contains tiny, invisible droplets of water. You've seen this happen on a humid day with a cold glass of lemonade. When the warm air hits the cold glass, it loses its ability to hold that moisture, and liquid water forms on the outside. An atmospheric water generator uses that exact principle. This machine creates a cold surface that pulls moisture right out of the passing air. The process happens in 3 steps. A fan pulls in the warm air, a cooling system chills it instantly, and a collection tray catches the water as it drips off the internal coils. This is a real-world industrial unit. In this warehouse, you can see the scale of the machinery required to harvest water from the atmosphere. It's an effective system, but it comes with a cost. To keep those internal parts cold enough to catch the water, the machine requires a significant amount of electricity. Even so, this technology allows people to generate clean drinking water from thin air, providing a lifeline in some of the driest places on Earth. NOT powers up a compact generator. Felix watches as a steady stream of fresh water pours out, filling his canteen for the journey. We've seen 2 different paths to the same goal, one that reaches deep into the earth and one that reaches up into the sky. These systems show how the human brain uses the laws of physics to solve problems. Whether we use gravity or electricity, the goal is to make the invisible visible. Engineering acts as a bridge. It allows life to exist in environments that would otherwise be too harsh to handle. Think about that the next time you pour a glass of water. Try to imagine the journey that water took through pipes, tunnels, or even the air to reach